things don't always go the way we had planned when working on big projects. If you find that your engine won't start once you've installed your Link ECU, there's no reason to panic. If you're lucky, it's normally a simple oversight. Other times, it can be a more serious issue. Regardless of what it is though, there are several things you can do to diagnose and rectify the issue. In this video, we'll walk you through the various checks that you can carry out to get your engine going. First of all, we should make a list of the things to check. Start from the most basic to the more in-depth, and work through it one by one. This hopefully saves us wasting time and going over the same thing multiple times. On our list today, we'll determine, are you dealing with a starter motor issue or a crank and no start? Check if your ECU is receiving power. Check your starter setup. Check if your ECU is locked. Check that your triggers are working. Check your base timing. Test spark. Test your fuel injectors. Check that the engine has enough air, and we'll verify you're not running into any cuts or protections. We're going to log various parameters to verify everything else is set up correctly. And lastly, we'll check the physical components of your engine to verify it's not a mechanical issue. So now with the plan of attack, let's begin. The first thing to determine is the nature of your no start. Is the engine turning over and not firing, or is the starter motor not working? If the starter is silent or it simply clicks as you turn the key, then you may have a starter issue. This video doesn't cover issues with the starter motor itself. It covers when the starter motor is working and the engine turns over, but the car will refuse to fire up. In some cases, the ECU is needed to enable the starter. We'll cover this shortly. Next up, check to see whether your ECU is receiving power. All Link ECUs have LED indicators to determine whether the ECU is receiving power. On our wire-in ECUs, this can be found on the front of the ECU next to the A-plug. This LED doubles as a check engine light. So don't worry if it's doing a slow series of long and short flashes, as this just indicates a fault code. It may be the reason your engine isn't starting, but it may also be a stored fault code from during the installation process. We'll cover working through fault codes in the limits and sensors section of the video. On plug-in ECUs, there are two LEDs on the ECU module. One is a power LED, the other is a check engine LED. Again, if the check engine light is flashing slowly, don't panic just yet. As long as you have an LED lit, your ECU is receiving power. If your ECU should have power, but the LED is not lit, you should check the fuses, check the relays, make sure they are seated fully, and also refer to your manual for power and ground pinout information and verify you have these wired correctly. If using a plug-in ECU, set any additional switches or jumpers that need to be set for your specific year, model, or location. Refer to your manual for specific options. Also for plugins, visually inspect the PCB, headers, and pins for damage, black or brown soot, or damaged or missing components. And finally, make sure your battery is fully charged and holding its charge. It's a good idea to hook up the car to a battery charger while you diagnose your no start. Once you have confirmed the LED is on, connect your ECU via PC Link. If the power lights are on or flickering and you still can't connect, it is possible the ECU is being backfed power. Remember, all aux switched relays must have their coil powered by ignition power, not constant power. If supplied constant battery voltage, they can be backfeeding into the ECU and keep it semi-powered up. It pays to check your vehicle's wiring diagram to see if any of the relays you are triggering stay live when the key is off. As an anti-theft measure, all Link ECUs arrive locked, meaning they cannot start an engine until an unlock code has been entered. If you see a message when you try to connect your ECU that it is locked, you should carry out the following. First, verify that the ECU is locked by going to ECU Controls and selecting ECU Unlocked. If the ECU enabled box is not checked, then your engine will not start, and you'll need to contact the dealer you purchased your ECU from to get the unlock code. Alternatively, you can contact our tech support team, and once proof of purchase has been provided, they can issue you with an unlock code. If you are a registered Link ECU reseller, you can obtain an unlock code by visiting the Link website. Go to the dealer store, enter your login details. Once you're logged in, click Unlock My ECU. Enter the serial number of the ECU to be unlocked, which should then be entered into the box on the ECU unlock screen. Click Unlock and receive your code. Now, you should be able to get the engine to turn over. With most older vehicles, the starter is controlled directly from the ignition barrel. Newer vehicles, however, can have ECU triggered or immobilized starters. If your starter is ECU controlled, then you'll need to check the starter control setup in the chassis and body section of PC Link. Also, be sure to check things like your clutch inhibitor switch, if equipped. Lastly, some cars will use the body control modules to control the starter. Check if the BCM is immobilizing. You may need to set up the CAN bus before you can try starting the car. In order for your ECU to fire correctly, it needs to know the position the engine is in. It does this with triggering. To eliminate any issues with triggers, we need to know if the ECU is receiving sufficient information from your trigger sensors. If you've been running fine with the factory ECU and have just switched to a Link, there is no guarantee that the triggers are working properly. There are known issues with engines such as the RB and the SR, where factory triggers can wear to the point where the Link can't interpret them. But the stock ECU still can, so it's vital that you perform this step. To check triggers in PC Link, connect to the ECU. Under ECU settings, go to Fuel, Fuel Main, and change the injector setup to off. Now press the F12 or the R key to see the runtime values, and navigate to Triggers/Limits tab. Crank your engine for 5 to 15 seconds and watch out for a few things here. While you crank, engine kill should be inactive. Percentage fuel cut, percentage ignition cut should be 0. Trig 1 signal and Trig 2 signal should turn from no to yes, though Trig 2 will only turn to yes if you have a cam or a sync sensor. It should be noted they'll show yes if anything that crosses the voltage thresholds is seen by the sensor. This does not mean the signals are valid or synchronized though. If the ECU cannot detect any signal, or the signal is not valid, then it cannot start the engine. You may only get a few cylinders firing before the trigger's fault. Engine speed should show a value. Anything from 150 to 500 is a good start. It probably shouldn't be over 1500 and certainly shouldn't jump erratically between 0 and 200 or 200 and 4000 for example. The Trig 1 error counter should not continually count up as you keep cranking, though it will count up a few times once you let off the starter. We also want to see the dwell value changing as you crank. If it does, it indicates that the triggers have synced and the ignition signal is being output by the ECU. The dwell value is a measured value and not a commanded value. If engine kill, fuel cut, or ignition cut become active, it could be any number of setup issues. We'll address these in the cuts and protection section. If you do not have Trig 1 signal and or Trig 2 signal, you should check the fuses and relays, as some trigger sensors are powered separately from the ECU. If you have a plug-in, check the jumper and switch settings match the information in your manual. Check that your Trigger 1 type and Trigger 2 type settings match your sensor types. Typically, 3-wire sensors are Hall effect, and 2-wire sensors are VR or reluctor. If you have 3-wire Hall effect sensors, they'll likely need the pull-up resistor turned on. Also worth checking that the sensors are actually receiving power too. If it turns out that you have issues with your sensors, then a trigger scope can help. So, we've now determined that you have a signal, but the engine still won't run. So, now let's see what the signal looks like. It could be misshapen, inverted, full of noise, too weak, or have other issues which could cause the ECU not to start the engine. On the G4X and newer ECUs, we can use the trigger scope function built into the ECU to diagnose the triggers. Early G4X Atom or Monsoon and some G4 Plus will only have a digital scope, but this can still be useful. If you have any other model of Link ECU, you'll need an oscilloscope, and you'll need to probe the pins on your ECU. With your ECU connected, in PC Link, go to ECU Controls, then Trigger Scope. Start to crank your engine. Wait for it to stabilize and press Capture. Continue to crank the engine for 10 to 15 seconds until you see an image similar to this on the screen. Then click Save. You can take a look in PC Link help file for some advice on what you're looking at, or you can email your file to tech support who can assist you. Always include a copy of your tune file with your log files. We've covered triggers, now let's move on to spark. We not only want to test that you have spark, but also that when the ECU drives a given coil, it fires on the desired cylinder. Should also go without mention, but if you've recently tested for fuel, be sure there is none sitting on or around the engine before we proceed. Start by checking your ignition setup. Make sure your settings match your engine. For example, if you have pairs of cylinders sharing a coil or ignition channel, make sure you have wasted spark set in PC Link. To do the ignition test, you'll need to pull out your coils. Place a spark plug in the end of each and ground the thread of the plugs. If you have a wiring mix-up or setup issue, and you take the coils off one at a time, it is possible to test one coil but have a different coil firing in the head when it shouldn't be. It's good practice to take them all out and test it once, to make sure that the commander coil is the one that's actually firing. In PC Link, Go to ECU settings, ignition, and then ignition test. Make sure the coils and plugs are positioned in a safe place. As you select each ignition drive, the corresponding coil should fire. Remember, this is in coil or cylinder order, not firing order. First, we'll check the firing order on our engine, which is a wasted spark setup in this example. The ignition drives should be wired in pairs based on the firing order. Ignition drive 1 is wired to the first cylinder in the firing order and to the other cylinder that is top dead center at the same time, which is half the number of cylinders further through the firing order. For example, on a waste spark V8, ignition drive 1 will be wired to the first and fifth cylinders in the firing order, while ignition drive 2 will be wired to the second and sixth cylinders in the firing order. In PC Link, go to the ECU settings menu on the left, look at configuration and firing order table. You can get the specific firing order information in your factory manual. Some engines may have this information on a label, on the valve cover, or printed somewhere else on the engine itself. Alternatively, you can get the information from the PC Link help file by searching for the engine-specific information topic. If the spark is weak, you may have a wiring issue, weak battery, blown fuse or relay, or a bad ground. You may also want to check your ignition module or igniter. If you're using a wire-in ECU, you may also need to splice in an igniter. Some stock ECUs have this on board with the ECU, such as the E36. You'll need to find the specific information out yourself. One thing to remember is that sometimes the ECU will make a spark in the open air without an igniter. It may even be enough to let the engine idle, but eventually there will not be enough power to run, especially under boost. It will feel like a soft ignition cut limiter in this case. If there is no spark at all, please make sure to perform the above checks anyway, but also make sure you check the wiring and spark gaps. Now we have one last trigger and spark related setting, and that is base timing. Let's look at this example trigger scope. Between the red arrow is one engine cycle, which is 2 crank revolutions or 720 degrees in a 4-stroke engine. You can see the blue trace after each arrow repeats, which it does for every cycle. Somewhere between the red arrows, cylinder 1 reaches top dead center. It might be on the red arrow, it might be 10, 90 or 180 degrees after the red arrow. It could also be before the red arrow. What we need to know is how many degrees are between top dead center on cylinder 1 and the red arrow, which is our sync tooth. You can measure this difference or trigger offset with a timing line. We have a full video on how to set base timing, so check out the links in the description to find out more. The injection test is functionally the same as the ignition test, but answers the question of when the ECU tries to drive the injectors, do they work? As a quick side note, the ignition and injection tests will only work on pins you have assigned as ignition or injection pins. If you have wired up an injector but not yet assigned it in PC Link, the test will not perform on that pin. The first thing to do is deactivate your fuel pump, either by unplugging it or deactivating it in PC Link by going to the fuel pump settings. When you're ready, go to Fuel, Fuel Setup and choose the injector test. Select each injector and test them one at a time. You can listen to or even touch each injector to ensure that the correct injector is firing. Like the ignition test, this is in a cylinder number order, not firing order. If you have injectors paired up for batch fire, you will need to determine yourself that they are paired correctly and check the settings in PC Link match your engine. If you are using low impedance injectors, these will most likely require ballast resistors. Link G4Xs and the G5 Voodoo Pro do not have onboard ballast resistors, so you may need to wire them in line. To check if you have low impedance injectors, measure the resistance across them. If they are less than 5 ohms, they are low impedance. Alternatively, some cars from factory have resistors wired into the factory loom. So if you have changed to high impedance injectors, you'll need to find and bypass the resistors. If your injectors aren't working at all, check the wiring, power, relays, and fuses. You can also try a test fire with some engine starter spray to see if your car will run independent of your fueling, to be sure you have a fueling issue. Although air problems aren't an ECU problem, you should check that the engine is getting enough air. Before cranking, check MAP and BAP are about the same value. This will tell you that your MAP sensor has the correct calibration applied. Refer to the MAP sensor calibration page in the PC help browser. Another sanity check is near sea level. MAP should be about 100 kPa or lesser in higher elevations. During cranking, it should dip below 100 kPa. If it doesn't, your map sensor might not be installed properly, or could be calibrated incorrectly. Or you may not have e-throttle configured correctly. Make sure to visually inspect the throttle carefully, as it is possible that the butterfly shaft can shear internally, giving the appearance that it is functioning correctly. Earlier, we looked at the runtime values window, and we checked if engine kill or any other fuel or ignition limits were active. Engine kill active means there is 100% fuel and ignition cut, which kills the engine. It's possible but unlikely that some other fuel or ignition cut is active too. So let's just check those in case. If engine kill is active, you should focus on these highlighted values in the runtime values window. The most common issue is ignition switch. If it has been set up in PC Link but not physically wired into the ECU, you'll get an inactive value, which will trigger engine kill. Have a read through the engine protection topic within the PC Link help files. It can be accessed by going to ECU tuning functions, runtime values and states, and then engine protection. This example table is set up in a way that will never allow the engine to start. Make sure that the RPM limit is set to an appropriately high value that will not interfere with the starting or idling of the engine. Another common example is setting the map limit table to boost values and not absolute values. For example, 50 kPa or 7 psi, when it would actually need to be 150 kPa. For more advice on limits, visit the engine protection section of the PC Link help file. Your Link ECU can detect when a sensor has failed or is not connected properly. In this example, the engine coolant temp sensor settings are typical. If the sensor becomes unplugged or a wire has broken, the ECU will detect the voltage has gone to 5 volts. If the sensor has a dead short to ground, the ECU will detect the voltage as 0. If you look at our ECT window, these voltages are outside of our default 0.05 volt to 4.95 volt range, so the ECU will flag that sensor has failed, though this range is configurable. When the ECU detects that a sensor has failed, it assumes the error value for the sensor. This should be set to a fail-safe value. For ECT, we typically set this to anything greater than the temperature the cooling fan switches on at. This means that if the sensor fails, the fans will come on and will hopefully stop the engine from overheating. However, it is possible that a combination of error values and RPM limits is stopping the engine from starting. This is easily done when you first install and set up an ECU. If the sensor failed and an RPM limit table has been set to 0 below the fail-safe value, then the engine won't start. This is because the RPM limit is being triggered by the fail-safe. Make sure your fail-safe values don't kill the engine if you don't want them to. Be sure to clear your fault codes. Some fault codes, such as e-throttle codes, require a power cycle before they clear. If you have a fault code that is returned, address it before you attempt to start your engine. Do not increase the limits, but instead fix the sensor that is at fault first. While this example is for RPM limit, it is equally possible for map limit or some other limit. So be sure to consider all of your limits and sensors associated with them. Note that your map limit value should be at least 15 kPa above barometric pressure, which should usually be 115 kPa at least for initial testing. You should also consider that a sensor may be working, but that the item being measured has genuinely failed. Check that the ECU's measured values are sane, your sensors are plumbed correctly, and that things are in good order. If you have confirmed everything we talked about so far, then there are very few ECU related things that will stop the engine from starting. Engines can usually start and run on a very wide set of conditions, so we're not going to be asking questions about how good the tune is or what the fuel table looks like. Instead, let's check that the ECU is happy with the overall fuel calculation and ignition timing. In PC Link, in the main layout, go to the General Logging tab, press F8 to start logging, or you can select logging along the top bar and press record. Now you should attempt to start your engine. Once done, press F8 to stop logging. Unless you have huge injectors, the injection effective PW and the injection actual PW should be between 5 and 15 milliseconds. They should also have a constant offset from one another. If either is 0 or 65 milliseconds or some extreme number, then check your injector settings. Check your dwell at the bottom too. It should be between 2 and 8 milliseconds. If it's around 0, then a setting with your ignition may be wrong, so go over those again. One possible reason for a 0 millisecond pulse width could be that you don't have a map sensor installed, but your fuel equation load source is set to map. If you have a plugin, be sure to read the manual that came with it. There is a guide included, which will talk about the first start, which may include how to adjust master fuel. By now, we get into the last of the possible issues. If you've got this far and followed the guide closely, chances are the issue isn't with the ECU. We've checked over a lot of things, but there have been certain assumptions. Just because the ECU can drive the coils and injectors doesn't necessarily mean they're firing when we crank, or that the fuel pump is working well enough to get the fuel into the cylinders, the valves are opening, or even that there isn't a hole in a piston. Repeat the ignition and injection processes, except this time you should visually check that the spark is firing when you crank and feel or listen for the injectors clicking. Inspect your spark plugs, plug gap, and verify their specifications against the manufacturer or tuner's recommendation. Upon inspecting the plugs, if they're wet, that means that the injectors are in fact working, but you may have flooded the engine. If you're still unable to get your engine started, there are a few places to ask for help and guidance. Your first port of call should be with the dealer who provided you the ECU, package or base map you're running. They may know what the cause is. You can also contact Link Tech Support for advice. To help speed up your request, you should have the following ready to send to the team: your tune file, the trigger scope file you created earlier, and the log file of an attempted start from earlier. Lastly, you can visit our forums at forums.linkecu.com. We really hope this video has been helpful and you haven't made it this far without getting your engine started. Thanks for watching.